Alright, now for the unit test of unit number 9, which is series. And let's start. Alright, this binomial theorem thing that I absolutely dread. Okay, so finish this Pascal triangle real quick. 4, 6, 4, 1, 5, 10, 10, 5, 1, 6, 15, 20, 15, 6, 1. That should be enough. Okay, so you write z and negative k 7 times, plus z negative k plus c negative k plus z negative k plus z negative k. That's 1, 2, 3, 4, 5. Z negative k. 1, 2, 3, 4, 5, 6, and 7. Okay, so for the first one, we for A we descend. So 6, 5, 4, 3, 2, 1, 0. And for the other one, we ascend, so 0, 1, 2, 3, 4, 5, 6. And for the coefficients, we just use Pascal's triangle. So we would use this one, I believe. Let's see, 1, 6, 15, 20, 15, 6, 1, yeah. Okay, just to make sure, I'm going to do 6 choose 4 is 15. So 6 choose 4, how many permutations? Alright, so 6 is 5 times 4 times 3. And that's the amount of permutations there are. We do divide that by 2. That. Yeah, it's 15. Wait. No, 6 times 5. 6 times 5 is 30. And that's the amount of permutations there are. Divide by 2 factorial for 50. Yeah, that's right. So, and we just evaluate. So c to 6 plus 6. We need to be careful about this time, because I messed up last time. Okay, so z to the 6 plus 6z to the 5th times negative k. So put a negative. So minus 6z to the 5th k plus negative. Wait, no. Plus, because negative k squared is just k squared. Yeah, negative k squared is just k squared. So 15 z to the 4th k squared plus 20. No, negative 20 z to the 3rd k to the 3rd plus 15z squared k to the 4th plus 6 negative minus 6ck to the 5th, 50k to the 5th plus, plus k to the 6, right? Hopefully I am not wrong. I want to say I'm not wrong. Alright, so z to 6 plus, minus 6 z to the 5th k plus 15 z to the 4th k squared minus 20 z to the 3rd k to the 3rd plus 15z squared k to the 4th minus 6z k to the 5th 6z k to the 5th plus k squared. K to the 6th. Hopefully I'm not wrong. Okay, thank God. Okay, new shopping mall okay, so this is automatically a geometric series formula, so I'll just write here for reference. Okay, so record 450 total shoppers on the first day, so A equals 150. Okay, so where don't I see 150? Okay, so it's not A or B 100%. Not A or B. After that, the number of shoppers is 15% more, so the common ratio is 1.15. That's the common ratio. So we have A, so we have A in the common ratio, and we are not given the end days of business, but we don't need to find that because that's not what the problem's asking. So 150, 1 minus 1.15 to n power over 1 minus 1.15. All right, and that one is C. Okay, the geometric series. So it looks to be that the common ratio is 1.5. That's -3. Yeah, -3 because -0.5 -0.5 times -3 is -0.5 times -3. -0.5 times -3. Yeah, it's 1.5. So just substitute everything in the formula. First term, -0.5, 1 minus common ratio, which found as -3. -3, and there are 45 terms. Where 1 minus -3, that's 4. Just evaluate this. -0.5, and 1 minus -3 to the 45th. All over 4. That's -3.69. Yeah, that's C. Okay, this is an arithmetic series where the common difference is -7 because we're subtracting 7 each time. So we find the sum. We were given the first term. We're given the last term. Now all we need to find is how many terms there are. So we can do -109 minus 150. -109 minus 150, and we can divide by the common difference, which is -7. Get 37. Add 1 to that, because you know, and then 38. We have 38 total terms, and just substitute all of this in the formula. So we have the average of the first and last term. So 150 minus 109. Or plus -109 times how many terms are, which is 38. So we find that. So 41 divided by 2 times 38 is 779. Okay, so we do n equals 0, so 0 plus, and then when n equals 2, and when n equals 1, 1, and when up to when n equals 2, another 2, so that's 3. A geometric series, find the sum of the first 25 terms. So the sum of the first 25 terms, it's the first term. 1 minus the common ratio, which looks to be 3/4, because let's say you want to find the second term, you do 8 times 3/4. So 3/4, how many terms? 25 terms. So 1 minus 3/4 is 0.25, or 1/4. So you just evaluate this in the calculator. 1 minus 3 or 4 to the 25th power divided by 0.25. You get approximately 31.97975, which is C. Oh my God, I don't want to do this. Okay, hopefully I do not get it wrong. Okay, so Just fill out some of this first. Okay, so P 4Q, and we need to do 4 of these. P and P 4Q plus P 4Q plus P 4Q. And the first one is descending, so 3, 2, 1, 0, and then 0, 1, 2, 3. And use Pascal's triangle, we get 1, 3, 3, 1. And we just evaluate this, so P to the third plus 3P squared, 3P squared 4Q, 3P squared, so 3 times 4 is 12, P squared Q plus 3P, wait, 4 squared is 16, times 3 is 48, so 48 PQ squared, and plus 4 cubed is 64, 64 Q to the third. I'm just gonna do this manually because I do not want to mess up. So P plus 4Q, FOIL this, P squared plus 4Q, 4PQ, just for good measure, plus another 4PQ plus 4Q squared, P squared plus 2, so 8PQ plus 4Q squared. I'll just move this up here. 4Q squared. Multiply that P plus 4Q again. P squared times P to the third plus 4PQ PQ squared. PQ squared plus 8P squared Q. AP squared Q plus 32 PQ squared and plus 4PQ squared, 4PQ squared plus 16Q to the third. We simplify all this. Just P and P to the third. Okay, so P to the third, yep, it's good. PQ squared, just PQ squared here, PQ squared here, and PQ squared here. 32 plus 4 is 36, plus another 4. That, wait, no, we have another, wait, we don't. PQ squared, we have PQ squared, 4PQ squared, wait, no. Wait a minute. P squared times 4Q is, yeah, it's 4 squared Q. What am I thinking? Oh my god, I have 3% battery. I have to make this quick. So P squared times P is P to the third times 4Q is 4P squared Q plus AP squared P squared Q, right, plus 32 PQ squared plus 4 PQ squared plus 16Q to the third. Okay, so what did I do here? So 4 to the, yeah, 60, should be 64. Or did I do anything wrong when I just foiled it? I really do not want to get it wrong here. Okay, so P to the third, we have that 4P squared Q. So we have one 4P squared Q here, another 4P squared Q here. And that's all we have, and that's 12. We have that right here. Okay, 32 PEQ squared, 4 PQ squared, that's 36. Where did I get 48 from? So 4 to the second is 16. 16 times 3 is 48, right? 32 PQ squared, 4, so 1, 1, 2, 3, 4, 5, 6. Of 1, 2, 3, 4, 5, 6. 16 P 32 PQ squared, 4 PQ squared, 16 Q to the third, 64, right? Should I just trust my gut and go with this answer? Oh, and I have 1% battery. I need to charge my iPad. Alright, I have my iPad charging now. Okay, so where were we? How about I'll just redo this. So P for Q, P for Q, P for Q, P for Q. Okay, descending 3, 2, 1, 0, 0, 1, 2, 3. Coefficients 1, 3, 3, 1. So P to the third plus 3P squared 4, 12 P squared Q, 12 P squared Q plus 12 P Q squared 16 times, 48 P Q squared plus 64 Q to the third. Yeah, I'm just gonna trust myself. I'm just gonna trust Pascal's triangle. I do not like this. Yeah, well, if I get it wrong, I get it wrong. No big deal, right? Yeah, whatever. P to the third plus 12P squared Q plus 48 PQ squared plus 64 Q to the third. Okay. Oh well. Let's see, I guess. Wait, or did I do, let me just, P plus 4Q, and P squared plus 4PQ plus 4PQ 16. Oh my. That changes everything. Yeah. 16 PQs. Yeah. Dang. Yes, so I am right. Okay. Yeah, I'm right. Wow. Okay, so again, Gmax series formula, A 1 minus common ratio to the, how many terms are 1 minus R. 10 swings, so S10. First swing, 20. Common ratio, she was doing 4, okay, so 1 minus 4/5. 10 swings. 1 minus 4/5 is 0.2. Enter all this in the calculator. And we have to round to the nearest meter, so we'll do that in the end. 4 over 5 to a 10th. Divided by 0.2. You get about 89 meters. Okay, last question. When x equals 1, 6, because 6 times 1 equals 6, and then 6, 2 equals 12. Add that together, you get 18. Imagine I get this one wrong. Okay. That's the unit test for series. Alright. On to, we only have one more left, and that's limits and continuity. This one's gonna take a while.